So this is just a quick recap on algebra for anyone who wants to look at it again or for anyone who happened to be absent during the lessons. So I started off by saying an equation is like a balance. Whatever you do to one side, you must do exactly the same to the other side in order to keep it balanced. So I did a thing with some jelly beans and some mystery bags containing jelly beans, and each of the mystery bags contains the same number of jelly beans as each other. So I've got 3 mystery bags, 2 jelly beans on one side, and that balances with, that's equal to 8 jelly beans on the other side. So we can represent that with algebra as 3x plus 2 equals 8. 3 mystery bags plus 2 jelly beans balances with is equal to 8 jelly beans. Now I can take things away from both sides. I can take 1 jelly bean from there, but if I take 1 jelly bean from there, then I have to take 1 jelly bean from the other side in order to maintain the balance. And in fact, I can take 2 jelly beans from each side before I run out of jelly beans. So 2 jelly beans taken from each side leaves me 3 mystery bags on the left and 6 jelly beans on the right. So 3x equals 6 in terms of algebra. Now I don't want to know what 3 mystery bags are, I want to know what 1 mystery bag is on its own. And if 3 bags have 6 jelly beans in, then 1 bag must have 2 jelly beans in. So let's just have a look at what I've done in terms of algebra. I started with 3x plus 2 equals 8. I did minus 2 both sides is important, to get 3x equals 6. And then I did divide by 3 both sides to get a single x on its own equals 2. So the final answer is that x equals 2, and in other words, each jelly bean or each bag had 2 jelly beans in it. So we did some examples. 5x minus 3 equals 2x plus 9. That's quite a much harder one because it's got minuses and it's because it's got x's on both sides. But if you think of the 2 x's and the 5 x's as bags of jelly beans, then perhaps it becomes a little easier to visualize. So I'm trying to get the x's on their own on one side and the numbers on their own on the other side. What I'm going to start by doing is to add 3 to both sides. Now the point of adding 3 to both sides is to cancel out this minus 3 and get the 5x on its own. So adding 3 to both sides, the minus 3 disappears and I get the 5x on its own. But because it's like a balance, I've got to add 3 to the other side as well. So instead of 9 jelly beans if you like, I've got 12. Next thing, I've got x's on both sides, and I'd really like the x's to be just on one side. So I've got 5 x's on the left and 2 x's on the right. So I could take away 2 x's, 2 bags of jelly beans if you like, from both sides. So I'm going to do that, minus 2x both sides, and that leaves me with 3 x's on the left. The 2 x's disappear from the right, but I've still got the odd 12. So 3x equals 12, but I don't want to know what 3 x's are, I want to know what 1x is on its own. So I'm going to divide everything by 3 and get that x equals 4. So we did some simple questions. If you like, you can pause the screen and have another go at these. So here come the answers. So 7x plus 6 equals 41. I took away the 6 from both sides to get the 7x's on their own. 7x equals 35. But I don't want to know what 7x's are. I want to know what 1x is on its own. So I divide everything by 7 both sides to get x equals 5. Right, so the next one, 3x plus 2 equals 35. I'd like to get the 3x bit on its own, so I take away 2 from both sides. So I've got to remember to take away 2 from the right-hand side as well. So 3x equals 33. I don't want to know what 3x's are, I want to know what 1x is on its own. So I divide everything by 3, remembering to do it both sides, to get x equals 11. And the next one, 2x plus 11 equals 18. So I want to get the 2x bit on its own, so I take away 11 from both sides, so I get 2x equals 7. But I don't want to know what 2x's are, I want to know what 1x is on its own, so I divide everything by 2 to get a single x equals 3.5. Next, 2x minus 3 equals 13. I'd like to get the 2x bit on its own, so I need to get rid of the minus 3. I get rid of a minus 3 by cancelling it out with a plus 3. So I add 3 to both sides, and the minus 3 disappears from the left. But I've got to remember that the right side has 3 added to it as well, so I get 2x equals 16. I don't want to know what 2x's are, I want to know what a single x is on its own, so I divide everything by 2 both sides to get x equals 8. Okay, so we did some questions from the book, page 191 onwards, exercise 9D, starting from question 3 and then moving on into 4, 5, 6 and 7. So the first one, just an example of how to set it out, x plus 2 equals 9, take away 2 from both sides, x equals 7. So important things about the layout here, things lined up, so the x's are lined up down the page, the equal signs are lined up down the page, and then you can see what's going on. So where you take away the 2 from both sides, you can see that the 2's disappeared, and it's easy to follow the working. Also, at this stage, I like the little notes on the side saying what you're doing both sides, and I like the answer double underlined. So quickly running through some answers, x plus 6 equals 15, take away 6 both sides, x equals 9. Next one, x plus 9 equals 20, take away 9 both sides, x equals 11. Here's some more. Probably just easiest to pause the screen if you want to look at these. They should be quite easy to follow because I've set things out nicely lined up. Same with these. And same with these. There's a question here that I've done 2 possible ways. So it was y minus a half equals 4. So probably the easiest way to do it is to just add the half to both sides and get y equals 4.5. So the homework on that day was to finish the particular block of questions you were on, because they came in blocks A, B, C, D, E. So you might have been on question 2C, so you needed to finish to the end of question 2, for example. Then on the 2nd of March, we did some questions. So if you like, you can pause the screen and have a go at those before moving on to the answers. And here come the answers. So question 1, 4x plus 8 equals 2x plus 72. So you could have done minus 8 both sides to get 4x equals 2x plus 64. Then you take away as much x as you can from both sides. So taking away 2 x's from both sides, 4x becomes 2x, the 2x disappears, and the 64 is still there. So 2x equals 64. I don't want to know what 2 x's are, I want to know what a single x is on its own. So I divide everything by 2 to get x equals 32. The next one, x over 3 plus 7 equals 31. So you could do that by taking away 7 from both sides to get x over 3 equals 24. Now I don't want to know what x over 3 is, I want to know what a whole x is on its own. So to get from x divided by 3 to a whole x, I need to multiply by 3 both sides. So multiplying by 3, the x over 3 becomes an x, but because it's like a balance, I need to remember to do exactly the same thing on the right hand side. So 24 times 72, 24 times 3 becomes 72. X equals 72. Okay, next one. Question 3, 6x plus 3 equals 10x plus 10. Now I always actually like to deal with the x's first and take away as much x as I can from both sides. So I've got 6 x's on the left and 10 x's on the right. So the most x I can take away from both sides is 6x. So I do minus 6x to both sides. The 6x disappears from the left and the 10x on the right goes down to 4x. So taking away 6x from both sides, I get 3 equals 4x plus 10. Then I'd like to get the 4x bit on its own. So I take away the 10 from both sides to just get the 4x bit on its own. But because it's like a balance, I need to remember to do exactly the same on the left-hand side. So 3 take away the 10 is minus 7. So I get minus 7 equals 4x. I don't want to know what 4x's are. I want to know what a single x is on its own. So I divide everything by 4 and I get minus 1.75 equals x. So that's the answer. X equals minus 1.75. Okay, so here's another one. 3x over 2 plus 5 equals 50. I'll start by taking away 5 from both sides to get 3x over 2 equals 45. I'd like to get rid of that fraction. So where it says over 2, that's dividing by 2, I want to cancel that out. So I'll cancel that out by multiplying by 2 to just give me the bit on the top, the 3x. But I need to remember to do that on both sides because it's like a balance. So 45 times 2 gives me 90. So I've got 3x equals 90. I don't want to know what 3x's are. I want to know what a single x is on its own. So I divide everything by 3 both sides to get 1x, or just x, equals 30. Next one, 15 minus 2x equals x plus 3. So this is a bit trickier because we've got minuses. I always like to try and get rid of minuses as early as I can. So I can get rid of that minus 2x by adding 2x. So when I add 2x, the minus 2x disappears and I'm left with just the 15. But because it's like a balance, I need to remember to add 2x to the right-hand side as well. So x becomes 3x when I add the 2x to both sides, and I get 15 equals 3x plus 3. Now, because I'd like to get the 3x bit on its own, I want the odd 3 to disappear. So I take away 3 from both sides, remembering to do it on the left-hand side as well. So I get 12 equals 3x. Now I don't want to know what 3x's are, I want to know what a single x is on its own. So I divide everything by 3 to get 4 equals x, and that's the answer, x equals 4. So we did some exercises, and they were from the MYP 3 book, page 158 onwards, exercise 8F, questions 1, 2, 3, and 4. And here are some answers from that. So 1G was 2x minus 7 equals minus 4. We added 7 to try and get the x bit on its own. So 2x equals 3. And then I don't want to know what 2x's are. I want to know what a single x is on its own. So I divided everything by 2 to get x equals 1.5. 1b, 4x plus 7 equals 27. I'd like to get the x bit on its own, so I take away the 7 to get 4x equals 20. But I don't want to know what 4x's are. I want to know what a single x is on its own. So I divide everything by 4 both sides to get x equals 5. 1d, 3x plus 1 equals minus 23. I take away the 1 to get the x bit on its own, and I get 3x equals minus 24. But because I just want to know what a single x is, I divide everything by 3 to get x equals minus 8. Next one, 11 plus 4x equals minus 6. Now, it sometimes confuses people to have the number first instead of the x first, but it works the same way. So I can take away 11 from both sides to get the 4x bit on its own, and I get 4x equals minus 17. But I don't want to know what 4x's are. I want to know what a single x is on its own. So I divide everything by 4 to get x equals minus 4.25. Here's another one. X plus 1 all divided by 3 equals 4. I'd like to get rid of the fraction, so I multiply everything by 3 to get just the top. X plus 1 equals 12. But I want to know what x is on its own, so I take away the 1 and I get x equals 11. Okay, so we moved on to brackets in algebra. Algebraic expressions often involve a quantity multiplied by a bracket, e.g. 3 brackets x plus 2. And that means 3 times everything in the bracket. So 3 times everything in the bracket gives you 3 times x is 3x, and 3 times 2 is 6. So 3 brackets x plus 2 is 3x plus 6. So we did some questions where we multiplied out some brackets. If you like, you can pause the screen and have a go at the questions before you see the answers. But just remember, where you see a minus sign, it belongs to the thing that follows it. So with 8x minus 6 here, the minus belongs to the 6. The minus is nothing to do with the 8x part. And that's worth remembering when you multiply these out. So the first one, 7 brackets x plus 3, 7 times the x gives you 7x, 7 times the 3 gives you 21, so it's 7x plus 21. Remember, these aren't equations. You weren't given something equal to something else. You were just given expressions without an equal sign, so you're not figuring out what x is, you're just writing the expression in a different way. Okay, the next one, 3 brackets 2 plus x, so 3 times the 2 gives you 6, and 3 times the x gives you 3x, so it's 6 plus 3x. Next one, 13 brackets 3x plus 11, so 13 times the 3x gives you 39x, and 13 times the 11 gives you 143. Now it gets tricky with the minuses. So we've got 4 brackets 8x minus 6. 4 times the 8x gives you 32x. And 4 times the minus 6 gives you minus 24. The last one is trickier still because we've got more minuses. So we've got minus 6 outside the bracket times 3x gives you minus 18x. And then minus 6 outside the bracket times minus 4 gives you plus 24, because minus times minus makes plus. So the answer's minus 18x plus 24. And now we're starting to do some with brackets. And these are equations because we are given something equal to something else. So we're going to figure out what x is. So first of all, multiply out the bracket. So minus 5 times brackets 4x plus 1 gives you minus 20x minus 5 equals minus 15. Add the 5 to both sides to get the x bit on its own, gives you minus 20x equals minus 10. And then we want to know just what x is, so we divide everything by the minus 20 to get x equals 0.5. Okay, the next one is another one with a fraction. 4x minus 1 over 5 equals 7. Multiply everything by 5 left and right to get 4x minus 1 equals 35. Get the x bit on its own by adding 1 to both sides. 4x equals 36. Then figure out what a single x is by dividing everything by 4, and x equals 9.